All right, so we've got a Data East MPU that is out of a time machine, and I went ahead and combined the two ROMs there into a single C5, which I've actually got Simpsons ROMs installed here on the board, which does work, even though it's a non-reflexive board, which just means that it's not going to computer control the special solenoids, but they are switch controlled. This thing here came in with a little bit of alkaline corrosion, so we've abated that. There was minor corrosion here in the components, and so the components that had alkaline on it were actually pulled and replaced. We've got a new CPU, we've got NVRAM installed, as well as new sockets here throughout. Got a new 470 UF capacitor, as well as a 47 new power input header. And then we've also got a new TIP 102 over here in the special solenoid section, which there's quite a bit of hackery that was going on over there. But let's go ahead and get this thing powered up. And as you can see, we've got the Simpsons ROMs installed, so that is the test that we're going to be running, which actually tests the board a little bit more as far as the display outputs and all that, given that the time machine was alphanumeric and alphanumeric on top and then numeric on the bottom, or the opposite, one of the two. Either way, this will fully test the board here, and here we're going through the switches, so just running through both rows and columns, and all 64 switches are reporting correctly. And we've got the lamp matrix, and then all of the columns, and then the single lamps, and that ghosting that you see is just a just from the LED block itself. That's not actually ghosting the lights there. And here's the flasher lamp, and then the coil test. So it's testing both A and B side here of the coil, with the relay switching the A and B side up there. Sorry, not a very good explanation. And then also the special solenoids, like I said, those are not computer driven since we have a non-reflexive board here, but as you can see, they are all switch driven there and working 100% now. And that actually concludes the test. So we are 100% good to go. Thank you so much. I'll go ahead and get the power supply here on the bench as well. So we've got the power supply on the bench here, and I've also got the PPB board here. So basically with this thing, we did have a burnt out TIP 36C that has been replaced. I've checked all the fuse clips and all the fuses, and we're good there. So I'm going to go ahead and grab voltages here from the power supply board, and so get the meter set voltage and start off with the -12 and then the +12 and 5 volts. And we've got the display voltage, so 5 volts here, then positive and negative there. And then moving over here, we should have, let's see, -12, and then +12, and then another +12, and a string of 5 volts here. So there we are 100% as far as voltages. And what I've done here is I've replaced all of the 0.156 headers. The CN1 pin 12 here on the wafer was actually burnt. So what I had done, and you can watch some of Chris Hibbler's videos, what he recommends doing rather than replacing the whole entire wafer is actually to extract one of the pins over here from CN2, which is not used, and to just swap the two there. Basically just replacing the one over here just gives it more a better connection. I can't think of the word I'm thinking of there. But anyways, we have replaced, let's see, C4 here. We've replaced C3 and C7 as well. And everything is 100% good to go on the power supply. So I will go ahead and get these boxed up and send back to you. Thank you so much.